gotta change that. Looks good. Do not disturb. Good morning, everybody. Welcome, welcome. It's 11:30 here. Just give me 1 second. I want to update these notes a little bit. And then we'll get started. We're going to review virtuals just for a little bit today. Talk about some other things, and then we'll get started on operator overloading. So today we're actually playing a little bit of catch-up. Usually we'd spend 2 days on virtuals, which we kind of are. But hopefully we can get caught up a little bit from the 2 Mondays that we missed at the beginning of the semester. And so I didn't clean up these notes from last time, but I'm doing it now. You can see I'm adding links for every single one of these things so that you can reference them to study for tests or, pretty much that for any future assignments that we might have. And I noticed that I didn't really describe what a virtual function is doing, so I'm just putting some of that in words right now. So I say, if a function is any kind of virtual in some class A, I guess would be better, what does it do? And so we'll say that any object of a class that inherits from class A, if stored in a pointer of base class A, It's a little bit hard to say. Any function, let's say if a function foo is any kind of virtual, anytime foo, there we go, is called from an object of a class that inherits from class A, if stored in a pointer of base class A, then foo from the derived class yeah, so that's a big hefty paragraph right there, isn't it? But we'll take one moment to talk about it. Probably didn't spell that right. All right. All right, so we'll go ahead and read that just one more time to make sure it makes sense. If a function foo is any kind of virtual in some class A, what does it do? So we'll say anytime foo is called from an object of a class B that inherits from class A, if stored in a pointer of base class A, then foo from the derived class B will be called as long as B has overridden foo. Yeah, so welcome to class. Do you guys have any questions about maybe the assignment or anything before we get started? I'm going to quickly kind of run through these notes again. And then we're going to do one more example with virtuals. So please let me know if you have any questions. Otherwise, I'm just going to kind of go through what we talked about last time, and we'll go from there. So just remember from last class, when we talk about virtuals, there's always some class involved. So whenever we're talking about virtuals, it has to do with classes. And if we are dealing with virtuals, there will always be a pointer to a base class involved. That's how we use virtuals. That's how we invoke virtual functions. And remember that this pointer is going to be holding an object of a derived class. So a good example of this is we have a base class player, which is going to be holding an object of a derived class ranger. And so how do the virtuals help us? We talked about this thing, runtime polymorphism, which kind of means many different forms, right? And so we will talk about polymorphism more today with operator overloading. But function overloading and function overrides are considered to be some sort of polymorphism. And so are virtuals, in which some function, usually with the same name, will take different forms. And we can call those different forms in different ways. And so then here, I already talked about this. Or you read it once at least. And this is what a virtual does. And we'll revisit that in my example today. And so then there's four kind of virtual things that we talk about. First, we talk about just the virtual function. So a virtual function will be any member function in a base class that has the keyword virtual in front of the prototype. So that would look something like this. Where we put virtual right in front of our class or our member function. And these functions are meant to be overridden in the derived class. And the overridden function in the derived class does not have to be virtual. It can be, though, if further classes will be derived from this derived class. Sorry, my computer skipped a heartbeat there, it seems. But we should be good to go now. And so the important thing to remember with this is that if we then, we're going to use this in our example today. Say we have a class B, and then we're going to inherit publicly from class A. And notice that we still have this void foo. And in A it says this is A, and in B it says this is B. If we do not make this virtual, and let's just kind of make a class C as well, why not? And I'll ask for a little bit of class participation here. So if you're ready to test your virtual skills, then feel free to speak up. So we have a class A, which, what does this look like, right? Let's go ahead and do a paint diagram so we can visualize what we're talking about here. It's going to be a very simple paint diagram. We'll also test our inheritance knowledge. So this is A, this is B, and this is C. Whoops. That's good enough. It's a little large, but I think that's fine. And then we're going to say that B is inheriting from A and C is inheriting from B. So my first question to you, is C an instance of A? Is any object of class C also an instance of class A? Yes, that is true. C is a B, and B is an A. B is also an A, and so because of that, C is also an A. So that's the first thing that we should remember. And now, what I was saying here is notice that this is not virtual. So let's say I come down in here, and I'm going to make some base pointers, okay? So we're going to have A, and we're just going to call it object 1 is equal to new B. Let's say we have A, object 2 is equal to new, well, let's mix it up here. We'll have A, object 3 is equal to new C. This is a little confusing. Let's kind of keep it in order, kind of alphabetical numerical order. And then I'm going to make a pointer B for object 4 is equal to new C. All right, so hopefully you guys are all okay with that. And then so let's say I call, and here's what I want you to do. When I call foo, now I'm just going to remind you guys that foo just says this is C, this is B, or this is A. That's all it says. And recall that in class A, this is a virtual function. In class B, it is not a virtual function. And in class C, it is not a virtual function. So as I type these out, can you guys tell me, starting with object 1, what will print? So this is an A. An object A is stored in this pointer of A. So which foo will be called? A, B, or C. Same for object 3. Object 4. Yeah. Object 1, 2, 3, and 4. And then we'll talk about it. Yes, that's exactly right. Sibe nails it. That's exactly right. So let's just talk about it real quick. So notice that this is an A. And so what we're talking about is from class A. Right. So Red Rose also posted an answer, and it is slightly different from Sibe. And this is where I think I may have confused you guys a little bit last class. I also wanted to try to make this text bigger. Let me try that real quick. Properties. Can I make this like plus maybe 12? And 800 maybe? See how that does. Oh gosh. Okay. We'll see how that works. I don't know if it'll actually make the text bigger, but I really hope it does. So, the first one here is really easy, right? This is going to say this is A. And that's because in this object, we're obviously just looking for the function A. So obviously it's right there. Regardless that it's virtual, we know that this foo belongs to A, so we'll call it. And then we're going to look for function B here, or object B, from the base class A. So we'll start in class A. Notice here that this is a virtual function. And so now we're going to go down this chain looking to see if we can find a B, which is going to be right here, right? So we'll go down one level and notice here that we found foo. And remember that it's virtual in this context, or it's virtual in class A. So we're going to say, hey, we found it. So this is going to say this is B. Now object 3, once again, this is where I probably confused you guys last time, so we're working that out. Remember that C is also an instance of class A. So C is also an instance of class B, but since B is an instance of class A, so is C. And so in fact, even that this is not virtual, even though this is not virtual, it's still going to find, it's still going to go down this chain of inheritance. It's going to look for everything that inherits from class A, every single class. Yes, exactly. As long as C inherits from A in some way, it's going to find it. And so it's going to say, hey, this is not a C, but this is a C, and this is inheriting from A. So this is going to say that this is C. Exactly. And then finally here, you guys got this one pretty right. This is going to say that this is B, right? And why is that? Well, that's because we're considering B as the base class, right? We're considering B as the base class in this instance. And notice that in the base class, this function is not virtual. It's not virtual. And so when we store an object of C within a B pointer, and we call foo from object 4, it's going to go in here and it's going to say, hey, this is not virtual, so I'm just going to call B. So let's go ahead and compile and run this. Just to confirm that we know what we're talking about. I've already got Bobby pulled up here, and I did save this just now, right? Yep. Oh, no. Let's go to here. Yeah. It's a little gloomy out today, isn't it? Oh, man. Did I do something? Whoa. Well, I'm glad that we did this. Because I am not okay with that. So this actually said that this is C. And so I wonder if we... Wow. Well, I'm glad that we did this then. Take some time to really figure out how virtuals work. because that really blows my mind a little bit. Obviously, now that none of them are virtual, well, we made this one, so let's see what we get. Are you guys confused yet? Because I definitely am. So, I guess... Yeah! I'm so sorry. So, I'm guessing that if this is virtual up here, in a way, if this is virtual up here, B has this function in a weird kind of way. Let's type it out here. Void a foo const. You know what I mean? In that this is a function override, and B is a class A. So let me find this. So B is an instance of class A. B is an instance of class A. And so since, in a weird way, B does have this virtual function foo. And so when we compile this, it will go down the line of command, I guess. It will say, hey, foo is a virtual. Even in B, foo is a virtual because it's inheriting from a class with a virtual. Now we could change this up. So let's make this a little different. So let's make a void foo1. So this is A, and we'll just say foo1 here. And then down here in B, we'll say that this is B foo1. And we'll make this one virtual. And then down here in C, we'll make another one. This is C. So now when we do this, let's make sure that we got everything correct here. So in A, this foo is going to be considered virtual for the entire line of inheritance. So anytime we call it, then it's going to be A, B, C, C. Okay, so I made that correction. Now in this case, when we call foo1, object 1 is an A. So we're going to see that this is A foo1. And then object 2 is a B, so we should even see it there, even though foo1 is virtual. Object 3 will be a C, right? And because it is virtual here, it'll go down the line until it finds C. And then when we're doing object B, well, wait a second. I guess we'll have to figure that out, right? Because maybe this one will be a, let's see. This one might just be, we'll see what this one is. But obviously this one will be a C. Right, I'm a little confused about this one here because we say that this is a base object of A, or this is a base pointer of A. And we're going to store C in here. And notice that this function is not virtual up here. But it is considered to be virtual in B. So my guess is that, well, can you guys guess what this one will be? If foo1 is not virtual in A, and we're going to call foo1 from this object, what do you think we'll see? I have a guess. Yeah, I like that. I like that guess, guys. Yeah, I'm going to guess that this is going to be an A because we're dealing with the base pointer of A. So I'm guessing we're going to see an A here. And let's take a look. Oh, man. Wait, no. Yeah, I messed up here. This is going to be A, right? This is going to be A, too. That was totally my bad. I totally made a mistake on that one. But that one makes sense, right? Because when we call foo1 from a base object A, because it's not... because this function is not virtual here, then of course it's not going to go to the B. Of course it's not going to go to the B. So that was totally my bad, but this should make sense, right? But the moment that we make this B object, it recognizes foo1 as a virtual, and then it goes down the line of inheritance there. So, you know, I always make mistakes. I think you guys know this by now. But I think we were able to kind of clear this up a little bit. Do you guys understand how virtual calling works? And should we spend some more time on talking about what kind of happened here with this virtual void A? I think this is a really good example that we should upload so you guys can reference. But hopefully we've got some understanding now of what or how virtuals work. Now these notes here are 100% correct from what we typed last time. This is a virtual function, virtual destructor, all that stuff. Virtuals are still the same. We just had to work a little bit more on figuring out how they're called. So please let me know, so we can spend some more time on it if we need to. Assignment 5 by any means is not hard at all. And there's really not very much going on in there regarding actual virtuals. I mean, you have to define some virtual functions, but it's there to give you an understanding of what's going on. By the weekend, I will have assignment 3 extra credit opportunity uploaded. And I'm going to go in there and I'll comment some blocks that need to be replaced. And so for those of you guys who are really looking to get into this virtual stuff, you'll have that as well. So that should be good. So I'll save this. This is going to be... Okay. So now we're going to move on to something called operator overloading, which is a form of polymorphism. Well, actually, before we do that, we have to do one thing. Have you guys heard of friend functions before? Let's go ahead and make our class student here. So we'll have a student constructor here that takes a first name, a last name, and it will take a float or GPA. And we will initialize all of these variables to look like this. And that's all we need to do. That's all we need to do there. So that is our constructor. Now let's say I wanted to make a print student function. Now obviously we've done this one before, right? Print student. const. And then somewhere in here, I'll just do like a cout. We've all seen this one before, mainly from assignment 2, right? Where we were printing out the AIS type. All right, that should be good. And then I want to do this. All right, so we've all seen this kind of print statement before. But let's say that I didn't want to have it as a member function, and instead, I wanted to have it as just a global function. Now, this is not very practical, but we're using it as an example, and it helps us with operator overloading, that is. So in order to print a student, I'm going to need to use a student parameter. All right, so let's go ahead and pass in a student s. It's probably not going to be constant because this is not a member function. And then I'm going to do this. Right away, you guys can tell me what is wrong with this, right? What kind of compiler error will this generate? I ask you guys. And then, follow-up question. If you want to answer it or not, what do you think friend functions will do for us in this instance? Give you a few more moments here. And so recall that we would call this down in main like this. We would declare some student, let's say S1, and we'll pass in James. Maybe just that part of my last name, and then let's give myself some GPA here, right? There we go. Yep, exactly. Member function, well, so CBase says it's not a member function of student. That's kind of part of it, right? We can pass it by reference. That's fine. We can do that. But the main problem is what Red Rose said, right? And it's that these are private. These are private members. And so, in fact, this function does not have access to them, right? So when we try to compile this code, it's going to say, hey, these are private. So we can remind ourselves of that because it is not a member function of the class, so it does not have access to those. It does not have access to those. It is private within this context. So a friend function is really cool, in which we can just say, hey, this function is a friend of the class. They're friends. And now that they're friends, we can access these private members. What? Why haven't we been doing that all along? Well, we haven't had much need for it yet. Friends are required. Friends are pretty much required for operator overloading. But up until now, we haven't really had a need for them. So now we can call print student on S1. And we should be able to print our student. Hopefully that makes sense. Pretty simple concept, right? Friend functions have access to private members and protected members of the class. So let's go ahead and let me find my notes. We'll start our notes for today. And I've got tons of notes open here everywhere. Everywhere, everywhere. So this is going to be friend functions. And friend functions make sense? Let me tab that. Maybe not tab, but we'll space it. So let's do a little bit of syntax. So say we've got a class A here, right? And within this class A, let's say we just have some, I'm going to do some shorthanding here. Say in class A, we've got a private in X. We'll go under. And then somewhere in this class, we list that, well, we're going to call it something like this. We're going to say void print A, and then it's going to take an A object and say it's coutts object dot, let me scroll up here a little bit. Say it prints out object dot x. So somewhere in here, if we say friend, void print A, then we know that they are friends. So that's really it. I'm going to just put this in the private section because I don't think it matters where we define this, but let's see. As you can see, it doesn't matter where we put it. So in the notes here, we'll leave that as that. And so as long as we put this in here, then they're friends. So now we'll begin with some operator overloading. So the first thing I'm going to give you guys is a link to some operators. And does anyone know, type in the chat if you'd like or not, what we mean by operator overloading? So here are all the C++ operators. Let me find my link. So I'll pull this up, and let's just take a look at some of these operators while we're here. I'm going to pull this over. So here's a bunch of operators in C++. We've used them plenty of times, right? So here we've got the arithmetic operators. So you've got plus, minus, multiplication, division, and mod. We've got our compound stuff. We've got our plus plus and our minus minus. Prefix and postfix. And if you remember me mentioning that earlier this semester, now we're going to really talk about what the prefix and postfix do. We have all of our Boolean operators. I guess we've got some logical operators, right? I guess yep. So there's just a huge list here, right? I'm not going to go through all of them, but you can see every single one here. Now, some of them are pretty important that we have to remember. Any of these operators can be overloaded except for a few. There's only a few operators that we can't overload. And so, in fact, all you have to do is run a Google search on that. And it makes it really easy for us. And we'll just kind of put it here. So we're going to say all operators can be overloaded except for these operators. So the first one is going to be the dot operator. This is the dot operator. The next one is the ternary. I saw one student, maybe a few more, using ternaries in their code. I was very happy to see that. If you remember me mentioning that, I think it was the first or second day of class. And that's just like an if statement, right? That's an if and an if expression kind of combined. But we can't overload that one. We cannot overload the scope resolution. We cannot overload the size of operator. This one kind of bothers me, right? Because it looks like a function. but it is actually considered to be an operator in C++. I don't even have to type that out. And then we also can't do this one. So we've got the type ID. And apparently this operator will give you the identifier for what type of the variable is. So we cannot overload any of these operators, but any other operator that we talked about, you can. So let me reference my notes here. Let's see what we got. So I'm going to give you an example of an operator overload. And so let's look at that. So say we've got an int x, which is equal to 0, 1, and then an int y, which is equal to 2. And if we see out x plus y, we're using an operator. And this will obviously give us 3. I don't think there's any question into that. Now let's assume we've got a string x, which will be equal to something like loaf, my cat's name, and maybe a string y for Patty, which is my other cat's name. So notice now if I see out x plus y, this is not going to do math addition, right? This is what I call math addition. You guys know the term for what this does for strings? I know I've mentioned it before. It is not math addition, but rather it's called something. I'll give you guys a chance if you'd like. But this is an operator overload of plus concatenate. That's exactly the word, right? It's not math addition. It's concatenation. Concatenation. Concatenate. That's when we concatenate the two strings together, and we'll get loaf Patty. Right? So this is an operator overload. It's an operator overload for string class. Does this make sense? I think so. So let's continue on here. Let me reference my notes once again. All right, so what are the requirements that we need? So the first thing we need is a class, some class that we defined. I mean, obviously, the string class has operator overloads, but when we're talking about what when we are operating overloads, or when we're overloading operators, we're talking about ones that we do. Structs will work as well. And then we need a C++ specified operator. Now, I'm going to throw a note in here. We cannot make our own operators, because it'll confuse the compiler. Compiler's not built to understand operators that we define for ourselves. So if we did something like, just like up there, if I said XAAY and we defined AA to be this operator, the compiler would have trouble figuring out whether or not that's a variable that we defined, or if it's like a function that we defined, something like that. If it's a type that we defined, it does not fall within the compiler's ability to do this. So we cannot make our own operators. At this point, might as well just make a function. Now, do you guys remember? I'll ask you once again. We already overloaded one operator this semester. Do you guys remember what it was? And there's one thing here I need to talk about. So we'll say, well, we'll wait for a response, if any. And to help you out with that, I think there's a delay we have in our stream, but it happened when we were doing the rule of 3. Do you remember that? When we were talking about pointers, it was maybe a class or two ago. You guys remember the rule of 3? And whenever we're doing rule of 3, we're talking about a class that has pointers in it, right, for dynamic memory allocation. And so we need the first thing, which is a destructor. The second thing we need is a copy constructor. And then the last thing we need is an assignment overload. So we've already overloaded the assignment operator. Let me see if I can pull that up so you guys know that we've got it somewhere. I think we made this dynamic array class. Do you see it here? All right, so hopefully you guys, yeah, so Aaron got that there. That's the equal sign, right? It's the equals overload. So we've already kind of seen this a little bit. And it looks like a function, right? And I even showed you down here, I think that we can even call it that way. Right, we said A is equal to A. We can also say A dot operator equal A. So we won't step too far into this, but I'm just kind of letting you know that an operator overload is kind of just a function. It's not too complicated. So some operators can be members of the class. Some operators can be globally or defined within a scope. We'll say globally for now. Globally defined. Not as a member. That's the key word here, is that some operators do not have to be members of the class. Though we're still going to have a class involved. This is where the friend functions come in. Let me put that in a note. Friend functions going on here. Friends. Guess I'll be more clear. Now, there's a few things that we have to take note of. First off, there are some operators that have to be members of the class, and there are some operators that have to be globally defined. So let's just answer that so you guys can reference it when we ask you this on a test or anything like that. So we'll say, what operators have to be member functions? Functions. Well, the first one is the assignment operator. So we already did this. And you guys know that it's defined as a member up here, right? It's within the class. It's a member function. So the assignment operator has to be a member function. Another one is the brackets. We're just calling brackets. And then the last one is the parentheses operator. That's an operator. So those are the only 3 operators that have to be member functions of the class. And I'll explain to you why that is in just a moment. And then we'll say what operators have to be global functions. Now, pretty sure there's only 2. We've got the insertion and the extraction operators. These ones always get me mixed up. So this is the insertion. I know that's kind of confusing, but imagine we're inserting to a stream, and this is the extraction operator. And when have we used these before? You guys have seen them. You might not have known them to be operators, but they are. And of course, we've seen these before when we talk about cout and cin, right? Yeah, CBA, you guys are already ahead of me. I can see it showing up there. That's cout and cin, right? And let me kind of give you a hint here. Notice I made this student class, right? Now pretend I didn't have this print student function. Somewhere down in main, if I said cout s1, now this kind of confused a lot of people, or I wouldn't say confused, but I just know in CS135, structs is one of the last things that you guys learn about. And when we were asking you to make a print function for assignment 1, this does not give a very good compiler error. Do you want to see what it is? Let's look at it. But all I'm saying is this won't work, right? Because this is a class, this is a struct that we defined, and this operator is not overloaded for this class. The error this gives is really disgusting, I'm pretty sure. But maybe we can find what it looks like. Yeah, so I know you guys have seen this before. I know. Look at this monstrosity. This is a monstrous. I know you guys have seen this error before. This is a monster error. And look at how far it goes up. What are you telling me at this point? You know what I mean? This is not helpful to me at all. But when we finally get up to the top, right? Look kind of what it says. It says no match for operator. No match for operator. So it is kind of telling you what's going on. But then it gives you this wall of text that doesn't help us at all in any way, right? But that's what it's saying. It says, hey, this operator's not overloaded. I don't know what to do with that. So let's get back to our notes here. So just remember, we'll talk about this. These ones have to be global functions, and that means we're gonna use friend functions. And then we'll say every other operator can be either member or non-member. Okay, so I'm not gonna list them all, right? But that's plus, you know, that's plus, that's multiplication. That's, what's another one? Let's just go look at C++, that link that I sent you guys. I guess I pulled it up here. See if we can find another one. Equals equals, that's a good one, right? Equals equals. So on and so forth. Is it etc, right? Etc. So far we're following along, hopefully. Now, let's just talk about this idea, and then we'll kind of begin with our example for today. Most of today will be notes, but we're almost finished with them, so we're doing pretty good here. So we'll just kind of comment this, and I just want to remind you that whenever we're calling, so let's come back to this example I have here. And this is a perfect example of that. So whenever we have an object, say we want to invoke a member. Some of you might not be comfortable with that word invoke, so just call a member function of that object, right? If I want to do that, I have to have an object, right? I have to have an object. So I might have a dynamic array. We have to call it something that I haven't used before, so J, and then I'll say something like J insert, right? Now notice that the object is on the left-hand side. Let's go ahead and put this in our notes because this is very important when it comes to operator overloading. And let's go ahead and define it up top here because we're going to talk about it a lot. And you'll hear it in CS 326. This is the left-hand side, and this is the right-hand side. So notice here that the J is on the left-hand side. The J is on the left-hand side here. And it always is. And so when we're talking about these operators here, there's always an object there is always an object of the class on the left-hand side. And that is why they have to be member functions. And so I'll just give you kind of an idea of that, right? Think about this thing up here again. There's no way I can call this where it means the same thing. I can't say like equal A, B or something like that. Maybe we could in a different world. But this doesn't really make sense. And so whenever we're assigning to something, there's always going to be an object on the left-hand side. Similarly, if we've got a bracket, right? Something like this. You guys know vectors before, right? We've done that plenty of times. Vectors have the brackets overloaded, right? Just like they're an array. There's no way that this doesn't make sense. And if we just call it like this, it's not operating on any kind of object. So there's always an object on the left-hand side. And then similarly, we haven't seen this one before, the parentheses, but they're kind of like these brackets in which the object is always on the left-hand side. And so because of that, we need to be able to invoke that operator from that object. Otherwise, there's no other way that we can call it. Now, take a guess if you want. No pressure. I'll give you maybe a minute or two. Let me find my notes. Can anyone guess why these cannot be member functions? And maybe I'll try to give you a hint while you're thinking about it. But let's say I've got this dynamic array J, and let's say I've overloaded this operator plus or something. Look, it's even telling me all this stuff. Let's say I've overloaded this operator plus for dynamic array. And so it might look like J plus, and let's say that it takes an int. So it might look like J plus int. And so this is if it's a member function, right? Because notice that the J is on the left-hand side. And then we can invoke this operator plus, and then it takes an int parameter. But if it's a global, then it will look like this. Now we're going to spend some time on this, so don't get too caught up in my kind of weird pseudocode that I'm doing here. But if we did it globally, the overload would look like this. In which we could say then J plus int. But if we happen to swap them, we could do it like this. In which then we have an int plus J. So notice here in the global that the object does not have to be on the left-hand side of the expression. Here it's on the right-hand side of the expression. So you guys have had some time here to think about it, and so I'll just kind of put the thoughts to rest. There's never an instance where these operators can be called with the object on the left-hand side. There's never. So similar to what we set up above, there is, sorry, I'm always making typos here. There's always an object of the class on the left-hand side. In this case, there is always an object of the class on the right-hand side. Right? Why is that? Cout object. Can you tell me what's on the left-hand side in this case? What is on the left-hand side of these expressions? If you've done string streams before, you may have not. But these are streams. Files, right? We can have an in file. So the point I'm just making is that the stream is always on the left-hand side. There's never where we've never have something like this where we're going to be inserting to the object. Rather, we'll extract into that object. Does that make sense? And so those are why. And so when I ask you on a test, I say, hey, why? I say, hey, why does the assignment operator have to be a member function? And you say, because there's always an object on the left-hand side of the assignment operator. And I'll say, hey, why does the insertion operator have to be a global function? And you say, because the object is always on the right-hand side of the insertion function. Do you guys have any questions about that? Why it is that way? The important thing is to always think about it like we're calling something, right? So in this sense, it'd be like if we said cout operator this, and then we'd have our object j. Never is it backwards where we call j operator cout. You know what I mean? I'll take your silence as an understanding here. So we're going to do some syntax stuff, and then we'll get started with whatever time we have left to start developing an example. Aaron says, I thought it is backwards with string streams. Well, let's go find out, shall we? Here's what I'm saying. I'm not going to compile this, but from what I can tell, and recall that this std is here because he didn't type in using namespace std. But in this case, they are, looks like inserting. I always have to check my notes for this. Yeah. They are inserting 100. I saw some of you guys would use this to convert your doubles from strings to doubles. Very creative. Where they would put in a string 100 and then they would try to extract it into like a double. It's very smart. But notice here, this, if you replace this with like cout, in this case you'll be putting 100 space 200 into this stream. And then when you're ready, you can extract from that stream into foo or bar. And then in this case it will print probably 200 for foo. Oh, it'll put 100 for foo, and then it'll print 200 for bar. Oh, string stream. Oh. Well, I'll let you spend some time on that, but do you know this? So we have the class fstream. Yes. Aaron, you say SS is an object of string stream. That is correct. And so let's see how someone uses it. So here's what I'm going to say about that. with the F stream, this is a file stream for input and output. An IF stream, which you've seen before, is an input. It's for input really only. And the upstream is only for output. So when it comes to string streams, this is the input-output version. And then the iString stream is the, I don't know why I'm even putting semicolons here, it doesn't matter, but this is the input version. And then the OString stream is the output version. Now, I don't use string streams too much, so I'm just referencing this example. So you could be correct. But from what it looks like here, they use a constructor on this ISS. They use a constructor of this string. And that's how they put values into it. So they're not even... all I'm trying to say is they're only using it one way here. Do you see that they're only extracting from the ISS? So they're only taking input from the ISS. But you could be correct. We can spend some more time on that in office hours if you'd like. But for now, we're going to finish up our operator overloading syntax. And, you know, I'll double check for you anyway, because it'd be good for me to know as well. So let's go ahead and do our syntax. So if we're going to do a global function, let's pretend that op is an operator. Let's put that up here. And so if we're going to do a global function, we need some type. And then we need the operator. And then we need whatever op it is. And then we need whatever params it takes. And then you've got your code. And that's it. And so we can do an example of that. Pretending that we have maybe a... I don't know, say we do string and addition. So let's do an example of that. So let's say we have the multiplication. So let's say we have string equals loaf. And then say we have an operator which returns a string, operator, multiplication, which takes a string and an int, which will have some code. And then this. And so then say we see out, let's call it s times 3. This operator might give us loaf, loaf, loaf. So notice that, we'll do this in the example, but notice that this operator is returning a string. It's returning a string. And say we're going to triple this, or we're going to take whatever int parameter is in here, and we're going to multiply this. It's not multiply, but we'll repeat this string 3 different times. So then we'll do our member functions. This one isn't all too different, right? But what's important here is that actually you're going to have the class is somewhere in here. I guess I'll put this in the comments. whatever class we're talking about, it has to be in the params somewhere. It doesn't matter where it appears. But with the member function, it won't have to. So if we're going to do the same thing, we're going to have some type. And then we're going to have some operator. Class A. And then we've got some params in here. And we might have some code in here. And the important part is that A does not have to be in the params. And so if we're going to do an example of that, the same one that we did up above, we would have our class string. And then in here, we would, I'm just going to kind of copy it. I don't see why not. But notice that this will return a string, but in this case, it does not need the string to be passed as a parameter because it's a member function. So that we're already assuming that there's going to be some object associated with this operator. So hopefully that makes sense. These are all the notes that we're going to do for operator overloading. Nothing really more than that. So we're going to get started here with our remaining 7 minutes to kind of work on an example. Whoops. And then we'll be done for the day. And then you guys won't see me for over a week, which I'm not sure if you guys are happy about that or not, but I imagine it'll be nice to have a break. So we're going to go ahead and make a string class for our example. And let's see if we can do an easy one, though I'm not sure. We're going to use this as an opportunity to practice dynamic memory allocation. Can anyone tell me how strings are stored before we had the string class? Does anyone have any ideas? If we didn't have a string class in C++, how do you think we would represent a string? We're going to call this string CS202. We'll have a private, we'll have a public, and in here we're going to, yeah, that's exactly right. We're going to have a character, we're going to have an array of characters. So guess what? There you have it. That's a character array. It's a character array. And then let's go have an int size. Why not? And let's go ahead and do our constructors because we'll have to do them anyway if we want to do anything about that. So for our default constructor, array will be initialized to, let's just say null. And our size will be initialized to 0. Destructor, let's remember the rule of 3, right? So I guess we'll start with that. Rule of 3. The first thing that we'll need for that is a destructor, string CS202. And in here, we're just going to call delete on the array. Right? That's our destructor. The next thing that we need is a copy constructor, right? So what is this going to take? This is going to take, I'm going to say a constant object because I don't want it to alter it. Copy. Right, so we've got the this object and we've got the copy object. Now I'm going to use this here because I'm just specifying which thing is going on. And I just want to see if you guys have been paying attention. Is this okay? No, no, yes is sufficient. What I just did. And is there any problems going on here? I know we're at the end of class here, so it might not be the best time to ask, but this is a shallow copy, right? You guys remember that? Because this is a pointer. Yeah, no. Yeah. So, no, it's not okay. This is not okay. Right? What do we have to do? We have to say this array is equal to new character size. Could be this size as well, right? So this array is, we have to allocate our memory, and then we got to do a for loop, right? Int I is equal to 0. I is less than this size, I plus plus. And then we'll say array dereferenced at location I is equal to the copy dot array dereferenced at location I. And then if we throw the this in there, that's just because I'm specifying the this from the copy, right? We have two different objects going on in here. So that is our copy constructor. And then we'll do the assignment overload, and then we'll call it for today. This makes sense, though, right? We got to do a deep copy here. So finally, we'll do the operator overload. It doesn't have to return anything. And so we can just come here and check our notes, right? Let's look at the syntax. We're going to do a member function. So I'll just copy this, right? I'll paste it right here. So what's the type of this operator? Let's say it's a void. I don't want it to return anything. What is the operator? Well, it's going to be an equal sign. What are our params? Well, in this case, we're going to do exactly this thing. And then guess what? I'm going to copy this entire thing because we have to do the exact same thing. But there's one thing going on here. And since we're running out of time, I won't. Red Rose asks, could we use the scope resolution to access the original string class and add new functionality with operator overloading? I would say yes. But you would have to pick an operator that's not already overloaded by the string class. So I'm unsure if there are any operators that they skipped. But if you tried to like redefine the concatenation operation, you'll get a compiler error. It says redefinition. You can't do this. But if string had a operator that was not overloaded, you could define an operator for that. Additionally, you could probably do some global operators as well. So maybe we can look into that a little bit next time. We are out of time, so I am going to just do this. And let me just say this real quick. Well, I'll save it for next time. There's a fun little trick here that we can do, but this is our first operator overload, and we're done for the day. So we talked about virtuals. We worked out our kinks, even my kinks, right? My lackluster understanding of virtuals, but we got that down. We talked about friend functions, and we began our discussion about operator overloading. If you guys have questions, you're always welcome to ask me. Even if I don't know the answer right away, I promise that I will help you get through it and help you get through it correctly, because I know how to do that. So ask questions if you need. Assignment 5 is due on the weekend. Get it done. It's not very difficult. Send me some messages, please. The extra credit opportunity will go up on the weekend, so look for that if you're looking to get some extra credit points. Like I said, I will add a small, PDF and some comments in that code just to guide you along the way. And that's that. I've got office hours in about 13 minutes, so please come to those if you'd like to chat. And that's all I got for you guys today. Thank you for coming to the stream. I hope you guys have a wonderful weekend. I hope you guys have a wonderful spring break. And that's it. That's the stream today. So you're welcome to go. Thank you for hanging in there with me. And I'll see you next time. Yep, you have a good break. Thank you. Catch you guys later.